Okay. Share my screen. All right. So if you're here yesterday, you'll know that we're trying to get the first position on this next bid. Um, there's 3 minutes left in the current auction. So yeah. Forgive me. I am extremely tired. Um, but yeah, I'm miyagod from Mia Maker. Um, we're trying to run this script, which works. And it also broke the other day, yesterday when we tried to run this. Is it here? Yeah, the gas API. Um, this one didn't work, but I found a new one. So when this gets down to 0 and this auction ends, and let's say nobody comes in the next 2 minutes and places a bid. Oh, wait, can everybody hear me? This happened yesterday. Can everybody hear me? Somebody want to respond in the chat? Yep, cool. Thanks, Mole. What's up, Mole? Um, but yeah, all right. We're just kind of playing the waiting game right now. So that means there's about 2 minutes left, 110 seconds. 107. So, yeah, this is the script that I'm running right here is the original bonkler script that I wrote in April of this year. I recovered it, which is awesome. So the code that is in the GitHub right here isn't really up to date. But where we left off, we were, using Web3 tools to talk to the blockchain. Um, and we can get deeper into the script in a minute here, but I do want to try to do this live because I think it would be cool to show. So 30 seconds. My heart always gets so fast. I kind of lose track of like how fast time works. All right, last time. 7 seconds. All right, here we go. Oh, missing argument. Was the transaction sent? Oh, bid sent though. Bid has been sent. I think I know where this is going wrong. I think something happened, guys. Oh, bid sent, but let's see. Oh, you guys see that? Does the class see what just happened? Bkong. So that's the wallet that I use. You'll see this number very soon. Um, hmm. Well, it's funny, bro. That see, if you were trying to bid through the front end, it wouldn't work for you right now because it doesn't seem to want to load. Um, but look, yeah, Bkongs, which is the wallet I'm using, got that first place. So when you hit the first, um, this isn't the first bid though. I don't want to show people the first bid. Uh, so yeah, so when you do win the first position, what happens is you actually also run the code for the previous day, which is why you do spend a little bit more gas. Um, but what happens is you actually end up doing the transfer of the ETH from the previous, from the actual bonkler wallet to the treasury. And then this is my ETH that came in for the new bonkler bid from here to there. Hmm. Oh no, so this is actually transferring the ETH from, yeah, I think to the treasury. But, oh no, this is actually transferring it to this wallet. But, anyways, yeah, beautiful. I used a higher max priority and max bid because if I could show you, um, we'll come back to that. But yeah, no, we just won. Cool, congratulations. Um, you witnessed it, everybody, all five of you. That was fun. It worked. It worked the way I wanted to. Yeah, cool. I'm kind of overjoyed right now. But yeah, so let's dig into kind of what just ran the in this script right here. So you can see these um, this stuff right, but this actually sent before we hit an error, and the error came from this line right here. Um, yeah, which I'm gonna change back to what it originally was. I changed this function yesterday, and I don't really like how it works. So we just do a three, and then, don't mind me, guys. I'm just fixing this up real quick for tomorrow. Okay. Um. So yeah. So this is the script that I just ran. Bonkler.py. Um. These are some libraries that we need or have been I use in order to get some stuff done. I am using environment variables. So yeah, I have like this address. So this address that I have in my environment um, sheet is the actual b.congs, the one that just fired right here. Um, got my private key, got my inferior key. So for my inferior, I use llama RPC, which gives you access to kind of you can get an API key for your own specific one. Yeah, I like it because it has all the new like privacy features and like anti front running um, shit, but it also has your own privacy private key or API key, so you get it's not like public, which is nice. And then yeah, I also use the gas key for this new. gas API that I used or found. Few different macros in terms of like max bidding. So here's actually that number that was the initial bid, the that we see right here. And if you go to ETH converter, which is a really super handy tool, you can see, hey, it cost that was 2.420042 ETH, which is what I sent right here. Let's see. Doesn't want to reload. But yeah, and then I also have a max bid, which was like, basically how much is in my wallet for a check later down in the script, and then an increment. Because what I also added to this script, which is why it tried firing again right here. So if you can see, like, went through that first iteration, that first loop, basically said, all right, it's not ready, so let's sleep until it is ready. And then went to second loop, but it was ready, so then it sent a bid at a certain block. Then I have this like kind of like fallback function where it waits until this is approved, right? And that's what this kind of wait for block is working with, as well as down, as well as we'll explain it in a little bit. And then this error hit where this feature that I added was supposed to work, but essentially it would wait until this transaction was completed, and then it would go through another loop where it would basically add this amount to the most current highest bid. So even if somebody came in and had a bot that say like bid next for me, like the next was the next bid after me, I would like bid off of them. But then yeah, and then it adds a certain amount to it, so that way it's higher. It needs to be higher than zero point 0.1, and this is like 0.1112, whatever. So yeah, and then it would basically go and then send another bid at a certain block. So this would actually loop until it reached this max bid amount. So the idea is that you chain together these bids all the way up until your wallet can't, right? Um, so here are some helper functions. Yeah, like I said, this is just get gas of like, what's like the current status of the gas on Ethereum. So you'll see these two numbers right here are like what I pull from that API. Um, and then, yeah, wait for next block, which I kind of just started explaining. Print now, which is really simple, just prints the current time. Is time, which is a function we'll get into in like really soon. And then this send transactions actually working with Flashbots. Yeah. So I wouldn't worry too much about it. This isn't integrated in right now, but it's something that I have here just because I have like tried to integrate it in the past. But I just found using Llama RPC is just as good. It's actually easier, more dependable actually. Okay, so what happens is when the script is ran, um, it tells it to go to this function run, right? And then so what happens is we print right now, which is this right here, right? And then we set up our Web3 provider, set up a session which allows us to manage our requests, um, which can be helpful when you're making a bunch of GET requests. Um, and then we set this flag too, which ties into that, um, like that feature that I was describing just a minute ago, where we are going to rebid after every successful bid. Um, let's just see. I just want to see. Cool. Um, but yeah, so what happens is then we hit our first like loop, which is basically everything that is going to run in the script will just run within this while loop. And we grab it's our first data, right? So from this API, let's see, better. Hmm. So yeah, their API is not responding because it says next bonkler ID is 1. But anyways, yeah, this is um, where we grab this information, and it's actually interesting because if I were to have grabbed, say, next bonkler ID, I would have gotten the like 1, you know. But what I do is I grab bonk ID plus 1 because there's been this issue before. So actually, because I did that, when I sent my transaction, instead of sending 1, which is what their API is responding with the next bonk ID, I had 106. So it worked. Nice. And then, yeah, so then we print out the bonker ID, which is, 106. This is the bonker that we want to bid on next. And then it runs through this kind of loop right here where it basically says, is it time yet? And is time grabs this end time, right? This bonker end time, which I've described in videos previously, but this is basically in Unix time, the second that this auction for this for 105 is supposed to end. And if somebody comes in before this, within the last 15 minutes, this will get reset to like another 15 minutes additional. And there's been times where, people have been bidding at the last minute, like back and forth and back and forth and back and forth for hours for certain bonklers. Um, but yeah, so it runs through that, and then it basically says, hey, here's the Unix time, ET, and here's the current time, T. And if T is greater than the the estimated end time, then return 0, which means it is time, right? That means like this Unix timestamp is in the past, and if not, return the difference between um, now and this end time that's in the future. And what that does is, if let's say it's not currently over, that means we get like a positive value back. So this condition will fail, and then it'll go say, hey, we're gonna go sleep for this amount of seconds, right? And that's what happens right here, right? Like, oh, it wasn't time, so we're gonna wait 6.8 blah 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 seconds, and then we go sleep for it, and then it comes back to here to this loop, checks to see it again. And then what happened was this runs fairly quickly. So within within a second and a half or so, I'd have to actually time it out. That's what print now is for. You can like kind of see like how quickly things run. But anyways, yeah, this runs again and it is time. So then we go. This condition is correct. So then now we go into this next while loop, which is everything now. Now that we've basically said this bonkler auction has ended, now we're going to loop into this bidding mechanism. So we do this for that reason. We make another get request for that reason, because when we loop back, we're going to need to grab the latest information. But we already know, which is pretty handy, we already know which ID we're using, right? So it's pretty cool. Anyways, we grab our information, and now we're starting to use Web3, right? So we get the latest nonce, which is just calling a get transaction count with address. And we get the balance, which is like how much ETH you have in your wallet of that address. This is the bonkler contract address. We get the block number, and that's for something later on. we do this function where we get the gas, right? We call this API, and then we set our max fee and our priority fee. And I actually added a buff. I added a buffer because there's been some competition lately where people have been, competing for this first block. And the way that you secure that is by getting a high position in the block. So you can see, look, I had the third position in the block, which means I had the third transaction that went in, or actually maybe the fourth, because there might be a zero position. But anyways, um, the reason that happened was because I had a higher max priority than everyone else. So there were actually, two people ahead of me who had a higher max priority because they wanted to, um, push their transaction through earlier than everybody else. Um, so if somebody, say came in, oh, see, this reverted. I think it's probably because you used the wrong generation hash, D5, no, 6A. See, he put one. Yeah, see how the API is kind of comical. Let's see how the API returns next bonkler ID equals one, and I was just talking about how I do bonkler ID plus one for this reason. Look, that's why his transaction failed. Live debugging of failed transactions, everyone. Um, but yeah, so I kind of lost my train of thought. But yeah, the position in the block, see how he's kind of lower on, and he is because his max priority is zero point 0.1 away. Um, and that's why I'm so high up, is because mine was, 23. Um, so we get our gas at it. And then this line here is explaining, it's like an if else that is dependent on the flag. If the flag is one, basically, we want the initial bid because it's the first time we've bid. You can see down here we set the flag to zero after we sent the transaction. So if the flag was zero, what we'd want to do is just say, hey, what's the current bid amount? And then let's add that minimal increment to that. And that's the actual value that we're going to use in this transaction. Before I explain the transaction, I'll just get to here real quick. These three lines are actually just some fancy Python, which does the creating of this hash input. What it does is right here, this is called a function indicator or function whatever. And you can see right here, see, if I wanted to call add generation hashes, I would use this DO3. Create bid is the C71. You can see it right here, C71. So it's the first 8 bits of your data that is actually going to tell the EVM which function you're trying to call at the address that you're sending to, right? So we're sending it to this bonkler address, but we're trying to call this function on that bonkler address, right? Um, yeah. So what we also need to do is then use buffered, I think it's 64 byte, buffered or 32 buffered inputs for this function. So when you call this function, you need to add the bonkler ID, right? The bonkler ID, and then also this generation hash, um, which I just explained, right? I had the correct one, which is this. And this is just 106 in hexadecimal, the 6A. But what I do is I take that 6A, which is this ID, right? The ID, and I format it to create a hex. This X actually creates a hex code out of it. So I take the two inputs, the ID and the generation hash, I make them hex inputs, and then I zfill 64 bytes, which puts all these zeros ahead of them, right? Puts all these zeros ahead of them, so it makes them 64 bytes. And then this final line, I concatenate it all. So I just say, hey, put this, then put the ID, then put the generation hash, and that's what comes out like this. It's pretty useful if you know, if you want to take a certain inputs and then create your own data out of it. These steps are pretty good. Um, yeah, all right. I'm gonna take 1 second to go grab some water, so I'm gonna go on mute. But I guess we lost some campers. Give me 1 second. I'll be right back. Okay. Excuse me. Um, yeah. So here's this transaction. Basically, this is to double check to see um, whether this amount that we're going to send is less than or equal to the max amount we have in our wallet. Because then if that's the case, then this transaction will fail. So we just exit. But let's say, this is that bid that we just sent, so it's actually under. So what happens is we create a transaction, um, add this information, who's sending the transaction, then what's the nonce of that wallet, here's our gas, where's it going, the value of the transaction, the message dot value, the data, message dot data, right? The stuff that we built right here. And then gas, which is the amount of gas units that we're using to send. Um, and this is actually just all you need for a create bid. Um, and there's actually a check in the code here that you can see on create bid that looks to see how much gas is left it requires. So like I've actually had transactions fail in the past because I was playing around with that number. So just use 200K. Oh, whoops, don't want to open Telegram, but it's going to open. Um, Shout out Remilios. Yeah, so then what we do is we use this function called sign transaction to actually use the private key to sign this transaction. And then we send it raw to Ethereum. This transaction receipt is the hexadecimal code for this transaction hash. So what I do is, like I was explaining a little bit before, is we basically wait for the next block, and then we say, hey, get the receipt for that transaction hash. And if there is nothing there, it's basically it's either stuck or hasn't processed yet, so then we're going to want to wait for the next block. And then if it is, then we're going to say, hey, the bid has been mined at this current transaction hash. And this right here, wait for next block, is actually where this broke because I had a different wait for next block function and I didn't change it down here, which actually ended up breaking it. But that's fine because I didn't really want it to run the next one because it's I've actually never had a successful like run up like from one to the next to the next. But yeah, um, that's the script. Um, and we got to see it work. That's really cool. Yeah, like I'm still the um first bid. So let's see, the front end is down still. Um, Yeah, I think that I'm gonna just end it right here. Um, so I guess one thing I could add, yeah, before I end it is future things I could do is one thing that I've thought of is using flashbots, or even I could just use, just kind of this raw transaction data to basically chain together them, like I was saying. But also I could use like different accounts. So things I've done in the past is like bid from Bkongs and then bid for Mia directly next to it to kind of like increase the floor of the bid quickly. And I could, if I could, what I could do is write some logic that could then, handle that. Um, and you could even utilize Flashbots to send it in a bundle, which allows you to send multiple transactions within one block that are like one after the other. Um, but yeah, I think what I'll do is say, hey, shout out Mia Maker, which is this open source project that we've been building. Um, Really cool. This is actually going to change fairly quickly. Not the layout design, but there will be some apps that come up. You can see our original token website right here. Whee! Which explains the Black-Hearted Cyber Angel Baby token, which is a token where you need to hold one of these NFT collections, which are all, cool milady derivatives that I like, that gives you access to this token. Um, yeah, and we have our first protocol coming out soon called miyaments, which is actually built off of this new token standard that we've built. And follow us at Twitter at miyamaker. But it's something that we is really cool. This is actually built off of NFTX. This guy's the founder of NFTX. Um, but yeah, it basically takes a portion of mint funds from an NFT and directs it to liquidity of a certain collection and like permanently locks it. So we kind of see it as a way for derivatives to align, not just like artistically or like like through their community, but actually through like financial, um, like support through, giving away or not giving away, but locking portion of your collection's mint fees in the liquidity of that, you know, collection that you're, sort of like paying homage to. Um, that's Zadomo. He's the smart contract dev, really awesome guy. Um, Also shout out to Krauser, who's the person who set up this beautiful application for us, the front end. Um, One thing I'll be doing, so this is the last bonker class. I won't be doing anything more with this bot, but what I'll be doing next, hopefully, is showing people how to build apps on this OS. Um, yeah, we were actually working on one last night. That's gonna be pretty cool. Yeah, you'll actually just be able to swap right here uh, for Mia tokens, which is pretty awesome. But yeah, so if you haven't already, hop into our Discord. Um, but yeah, I think what I'll do is I'll hop into the lounge just to take some questions if either of you have any. Thanks for sticking through with this the whole time. I know it's either early or late, where a lot of people are, so I appreciate it. And yeah, it's fucking awesome. We won. uh, so congratulations. First bonkler bot in history that's ever been filmed live for an audience. um, Beautiful. All right. Well, I will hop, like I said, into the lounge for a short Q&A if you guys are down. But yeah, thanks again for showing up. Talk to you soon.